Okay, we're back.
Okay, so I'm not exactly sure where I left off, but again, the idea here is that we're looking at a divergent plate boundary, and that you can simulate this by pulling paper in two equal directions from a single point in the cardboard. And you can do this at two places in the cardboard, because this is what often happens in the ocean. We don't just have one continuous line of divergence, but we have these places where we have new rock forming and then moving away, and then in between what you can see is that there are two different pieces of land that are sliding past each other. So if I keep pulling this side and then this side simultaneously, you can see that this area right here is where two plates slide past each other, and that's very similar to a transform plate boundary like we see along the San Andreas Fault in California. So that's an important feature to point out to students when they are making their divergent plate boundaries, that you can also have these transform areas in between, again showing where plates slide past one another. So then the next plate boundary that we're going to, so that was two. We already went over divergent and then transform plate boundaries. The next type of plate boundary that we're going to go over is a subduction zone or a convergent plate boundary. So this is when one plate literally goes underneath another, and in my notes I'll be explaining to you why this happens, and so then you can explain to the kids why at certain points on Earth we have things like convergent plate boundaries. But the idea here is that students will start to understand that this is a place where you have things like volcanoes forming. So students can make volcanoes on their model, and that would volcanoes form on the plate that's staying on top, not the one that's going down, but that volcanoes form in that top plate. And now what I'm going to do is pull this green plate under the top plate, and that is the convergent plate boundary right here as one goes under. Now I have a napkin that's paper clipped on top of this piece of paper, and this napkin actually represents all of the sediments, sand and even finer stuff, all sorts of ooze from little organisms that live in the ocean that sits on the bottom of the ocean. And what very often happens is plates that make up the bottom of the ocean will sink below the continents where we would have things like volcanoes. So what this simulates as I pull this plate down is the folding of these sediments and the scraping off of these sediments onto the continent as the plate sinks below, one plate sinks below the other. So that is showing again the convergent plate boundary, and this actual structure that's formed by the napkin is called an accretionary wedge. And again, in my notes I'll give you a little more background on what an accretionary wedge is, but again it's about the scraping off of that stuff that accumulates on the plates in the ocean that then will often get stuck onto continents. And that's why we have all these different types of rocks along the coast in California in certain places, because we have that accretionary wedge formation. So I think that explains most of just how this works, and I will give you this model to Janet so that she can hopefully help you understand a bit more, and you can ask me any questions as well.
Wonderful, thank
Thanks,
you.
guys.